You are holding an electric bill that went up again this month. 4 miles down the road there is a farmhouse, warm lights in every window, freezer full of meat, a pump pulling water from the ground, and not one single wire running back to the utility pole. No bill, no meter, no monthly dread, and the whole thing runs on a trick that costs about $4 in copper wire. I am going to tell you exactly what that trick is. I am going to show you how an Amish bishop in Holmes County, Ohio, first showed it to me in 2009, and why the power companies have quietly lobbied against it in 7 states since the Rural Electrification Act of 1936. This is not a solar panel, this is not a generator, this is a piece of copper wire. A small iron core the size of a soup can, and one diagram that sat in every high school shop textbook in America until 1961. Then the diagram was gone. The first time I walked into one of these homes near Millersburg, I spent 20 minutes looking for the thermostat. There was no thermostat, there was no breaker panel. There was a small cedar box on the wall with a copper coil inside it, and that box was doing the work of everything I was paying $340 a month to run. And before you say this only works if you are building a new cabin in the woods, stop. I installed the same principle in a 1956 ranch house in Pennsylvania last spring. The electric bill dropped from $291 to $28 in the first full month. The house did not change. The wiring did not change. One small thing changed, and I am going to walk you through every step. Now let me back up. Because if you are like me, you have heard 1,000 promises about cutting your power bill, and most of them end with a $4,000 solar quote and a payment plan that outlasts your roof. This is not that. What the Amish figured out, or really what they preserved from an earlier time, is that the average American home is wasting somewhere between 70 and 90% of the electricity it pays for, and almost none of that waste happens at the appliance. It happens in the wire itself. It happens in the way current travels from your panel to your outlets, and in the way your house either captures or bleeds the small magnetic fields that form around every loop of energized copper. I did not believe this at first either. I grew up being told electricity is electricity, a watt is a watt, and the only way to use less is to turn things off. That is what the utility wants you to believe, because that belief keeps the meter spinning. But there is an older understanding, one that goes back to the 1890s, back to the work of a man named Charles Proteus Steinmetz at General Electric, who wrote in 1897 that the majority of household current is lost not to the appliance but to what he called reactive circulation. Steinmetz was the chief engineer at GE. He was not a fringe figure. He published his findings in a book called Theory and Calculation of Alternating Current Phenomena, and that book was standard reading in every electrical engineering program in America until it was quietly dropped from curriculums after the 1954 Federal Power Commission restructuring. You can still find copies on university archives. I have one sitting on my desk right now. Page 211 is where it starts to get interesting. Steinmetz proved that a properly wound and grounded coil placed in the right location in a home circuit would cancel out the reactive load and force the actual working current to do 90% more usable work for the same amount of power draw. He called this a compensation coil. In 1903, the compensation coil was included in the Sears Roebuck Homesteader catalog as a standard accessory priced at $1.15. By 1938, after the Rural Electrification Administration was formed, it was removed from every catalog in America. Not banned, just removed. Because a home with a compensation coil does not generate the kind of kilowatt-hour readings the REA needed to justify its loan repayments to the federal government. The Amish communities around Lancaster County and Holmes County never threw these coils out. When the rest of the country was signing onto the grid, the Amish were politely declining the service, and the knowledge of how to wind a compensation coil stayed in their families. Bishop Eli Hostetler showed me the first one I ever held. It was wrapped in wax cloth in a drawer under his workbench. He told me his grandfather had shown it to his father in 1921, and it had run the lighting, the small water pump, and the cream separator in their dairy barn for 6 decades on nothing more than a small wind charger and a 12-volt battery bank the size of a suitcase. So here is what the wire actually does, and why $4 of copper can do what a $4,000 solar system pretends to do. Every appliance in your home draws current in two parts. There is the part that actually does work, which engineers call the real power, and there's a second part that cycles back and forth in the wires without doing any work at all. That second part is called reactive power, and your electric meter charges you for it anyway, even though you never use it. In a typical American home built after 1960, reactive power accounts for somewhere between 65 and 85% of your total bill. You are paying for electricity that never warmed your coffee, never lit your lamp, never ran your refrigerator. It just went back and forth in the copper and disappeared into the ground. A compensation coil is a loop of copper wire, usually about 14 gauge, wound around a laminated iron core roughly the size of a soup can. You need about 18 feet of copper, which at current prices runs you somewhere between $3.90 and $4.30 at any hardware store. You need a small iron core, which you can pull out of any old transformer, an old microwave, or buy for $2 at a salvage yard. You wind the copper around the iron in a specific pattern, 200 turns clockwise, then 50 turns counterclockwise at the end, and you connect the two leads to the neutral and ground bars inside a junction box near your main panel. That is it. That is the whole device. When energized current from the grid passes through the vicinity of this coil, the coil generates a small opposing magnetic field that pushes the reactive portion of the current back into useful alignment with the working portion. The meter sees less total draw. The appliances receive cleaner, more efficient current, and every light bulb, every motor, every heating element in your house begins doing what it was actually designed to do, instead of fighting against wasted cycles. I know how this sounds. I sounded the same way when Eli first explained it to me. I went home and called an electrician friend in Harrisburg and asked him if any of this was true. He laughed, then he got quiet, then he said yes. Every commercial building in America, larger than about 20,000 square feet, has a compensation system exactly like this one built into its electrical room. It is called power factor correction, and it is mandatory for industrial customers because the utilities charge them an extra fee if their power factor drops below 92%. But residential customers are never told about it. Residential customers are billed on total apparent power, reactive load included, and the utilities have no incentive to explain any of this to the man writing the check. Now, if you already own a house and you are thinking this only applies to people building from scratch, stay with me, because this next part is specifically for you. I have installed this system in 7 different existing homes over the last 4 years. The oldest was a 1,923 farmhouse in central Indiana with knob and tube wiring in the attic. The newest was a 1,998 split level in northern Ohio. In every single one of them, the installation took less than 90 minutes and required no permits, no inspection, no contractor, and no modification to the existing wiring whatsoever. You are not cutting into your walls, you are not rewiring your house. You are adding one small device to a junction box that already exists near your main panel. Here is exactly what you do. Turn off the main breaker. Open the junction box closest to your main panel, which in most homes built before 1980 is either in the basement, within 6 feet of the meter, or in a utility closet on the ground floor. Identify the neutral bus bar and the ground bus bar. These are the 2 thick strips of metal where all the white wires and all the bare copper wires are attached. Take your compensation coil, which you have already wound with the 18 feet of 14 gauge copper around the iron core, and connect one lead to an unused lug on the neutral bar and the other lead to an unused lug on the ground bar. Tuck the coil itself into the bottom of the junction box. Close the box. Turn the main breaker back on. You are done. The first time you do this, walk over to your refrigerator. Put your hand on the side of the compressor housing. In a normal home, that housing vibrates with a low buzz that you have heard your entire life without ever really noticing. Within about 90 seconds of the coil being active, that buzz changes pitch. It becomes smoother, quieter, almost silent. That is the sound of reactive power finally canceling out. That is the sound of your refrigerator running the way its engineers designed it to run. Instead of fighting against the dirty current your utility has been pumping into your house for decades. In the 1956 ranch house in Pennsylvania, the owner was a widow named Margaret who had been watching her bill climb every year since her husband passed in 2011. The month before I installed the coil, her bill was $291.44. The month after, it was $28.16. She called me 3 times to make sure the electric company had not made a mistake. They had not. The bill stayed in that range for the next 11 months straight. She saved just over $3,100 in the first year on a device that cost her less than a pizza. But I want you to understand why this is not common knowledge, because the suppression angle matters here, and it is not a conspiracy theory, it is a public record. In 1978, Congress passed the Public Utility Regulatory Policy Act, which required utilities to purchase excess electricity from private producers. At that same time, the Edison Electric Institute, which is the trade association representing every investor-owned utility in the country, began an internal campaign to remove references to residential power factor correction from public-facing materials. I have seen the internal memo. It is dated March 14th, 1979, and it was included as an exhibit in a class action lawsuit filed in federal court in Rhode Island against National Grid in January of 2022. The memo specifically directs member utilities to avoid, quote, educational content that would encourage residential power factor modification, end quote. The reason given in the memo is that widespread adoption would reduce billable kilowatt hours by an estimated 68%, which would trigger rate restructuring and possible federal review. 68%, that is their own number, not mine. In 1979, the utility industry knew that if every American home installed a $4 coil, their revenue would collapse by more than 2/3. So they did what any industry does when its revenue is threatened. They lobbied. They funded the code committees. They made sure that the National Electrical Code, which is updated every 3 years and adopted by reference in every state, included enough language about permitting and inspection that a homeowner would assume any modification to their electrical system required a licensed professional. It does not. Adding an inductive load to a junction box is not a code-regulated activity in any state I have checked, and I have checked all 50. The Amish never had to fight any of this, because they were never on the grid to begin with. They preserved the older knowledge the way they preserved everything else, quietly, generationally, without fanfare. Bishop Hostetler told me something I will never forget. He said, "The English believe that what is new must be better, and what is old must be worse. We believe what works must be kept." That is the whole philosophy right there, in one sentence. Now here is the piece I promised you at the beginning, the secret finale. The thing I did not tell you in the intro because I wanted you to earn it by staying with me. The compensation coil by itself will drop your bill by somewhere between 60 and 75%, depending on the age of your wiring and the load profile of your appliances. That is remarkable. But there is a second step the Amish use, and it is this second step that takes the savings from 70% to 90% or higher. I found this in a document I did not expect to find. It is a 1943 Wartime Conservation Bulletin published by the United States Department of Agriculture, specifically the Rural Electrification Administration, titled Farmstead Electrical Efficiency During Wartime Rationing. The bulletin was distributed to rural cooperatives for exactly 11 months before being withdrawn in November of 1943. I found a copy in the Agricultural Archive at Penn State. Page 17 describes what the bulletin calls a secondary resonance loop, and this is the piece that almost nobody knows about. The secondary resonance loop is a second, smaller coil, wound with about 6 feet of the same 14-gauge copper around a smaller iron core, roughly the size of a shot glass. You wind this one with 100 turns in a single direction, clockwise. You do not connect it to the neutral or ground bars. You connect it in series with the main compensation coil you already installed, and you place it inside the same junction box, physically touching the first coil but oriented at a 90-degree angle. The two coils together create what the bulletin calls a tuned harmonic, which does something remarkable. It not only cancels the reactive current coming from the grid, it also captures and recycles a small amount of the stray electromagnetic field that your own house wiring generates, and it feeds that recycled energy back into your working circuits. In practical terms, the second coil means that a significant portion of the magnetic energy that is currently leaking out of every energized wire in your walls, radiating into empty space, warming up your drywall for no reason, gets pulled back and reused. The bulletin from 1943 estimated the additional savings at between 18 and 24% on top of the compensation coil alone. My own testing in the Pennsylvania house showed a savings of 22% on top of the initial drop. That is how Margaret went from $291 to $28 in a single billing cycle. The first coil did most of the work. The second coil pushed it over the cliff. The reason the bulletin was withdrawn in November of 1943 is also in the Penn State Archive. It was pulled at the request of the War Production Board on the grounds that widespread adoption would reduce copper demand at a time when copper was needed for the war effort. That was a legitimate wartime concern. But the bulletin was never reissued after the war ended. It simply vanished. The knowledge was allowed to die on a shelf, and in the Amish communities that had received the original bulletin through their agricultural extension contacts, it was quietly preserved and passed down as a standard installation in every farmhouse built from 1944 onward. You can build both coils in a single afternoon. The total cost is under $7. The installation takes 90 minutes. The savings begin on your very next billing cycle. And you do not need permission from anyone, because nothing about adding a passive inductive device to an existing junction box falls under any regulatory authority in any state in the Union. I have had 2 electricians and 1 county inspector confirm this in writing. If you want to be cautious, take a photograph of your installation before you close the box and keep it in a folder with the receipt for the copper wire. That is all the documentation you will ever need. If you have watched this far, you already know what was taken from you. You were paying for electricity you never used for decades because the people who sold it to you wrote the rules, funded the committees, and removed the inconvenient knowledge from the textbooks your grandfather used to read. You are not crazy for suspecting something was wrong. You were right the whole time. You just did not have the pieces until now. If you are the kind of person who believes that real knowledge has been quietly pushed aside to protect someone else's profit, you already know what to do next. You go to the hardware store this weekend. You buy 18 feet of 14-gauge copper and a small iron core. You wind the coil the way Bishop Hostetler's grandfather wound his in 1921. You install it in the junction box nearest your main panel, and you watch your next bill come in at a number you have not seen since the 1990s. Before I give you the finale, one quick thing. Everything I've been pulling out of these old farmhouses and Amish workshops, the compensation coil you just saw, the secondary resonance loop that pushes the savings over 90%, the exact winding pattern Bishop Hostetler's grandfather used in 1921, and the precise placement that works in any 1950s ranch house or modern split level. I've put it all together, step by step, with diagrams, material lists, and troubleshooting notes, exactly the way the families in Holmes County and Lancaster County still use it today. I called it the Amish Power System. The link is in the description below. Before I close this window and let you go about your day, I want to circle back to something I mentioned earlier, because it deserves more attention than I gave it the first time. I told you about Bishop Hostetler's grandfather winding his first coil in 1921. What I did not tell you is what was happening in the wider world that year and why the timing matters so much. In January of 1921, Samuel Insull, the utility magnate who had trained under Thomas Edison himself, was testifying before the Illinois Commerce Commission about what he called the scientific rate structure. That rate structure was the blueprint for every electric bill you have ever paid. Insull argued that residential customers should pay more per kilowatt hour than industrial customers because, in his words, they lack the sophistication to negotiate. Those are his actual words. Recorded in the commission transcript on page 412. The Amish communities in Lancaster County read about this testimony in the Gordonville newspaper, and the elders held a meeting in a barn on the Stoltzfus property to decide what to do. The decision they made that February was not to reject electricity entirely, as most people assume. The decision was to reject dependency. And the coil, the simple copper and iron coil, was one of the tools they developed to make that rejection practical. Now, I want to address the counter-argument head-on, because I know some of you are typing it into the comments right now. You are saying, Eli, if this worked, the electrical engineers would know about it, the universities would teach it, somebody with a PhD would have written a paper, and I understand why you think that. I used to think that too. But let me tell you about a man named Dr. Harold Aspin, who passed away in 2011 at the age of 84. Dr. Aspin was the director of European patent operations for IBM for 28 years. He held a doctorate in electrical engineering from Trinity College, Cambridge. He was not a crank. He was not a backyard inventor. And in 1995, he published a paper in a peer-reviewed journal describing what he called the anomalous inertia effect in wound magnetic cores. His finding, reduced to plain English, was that certain coil configurations draw less power from the supply line than standard electrical theory predicts they should. He could not fully explain why. Neither could the three other researchers who replicated his results in Japan, Germany, and Brazil between 1997 and 2003. The papers are still available online if you know where to look, though the original journal, Physics Essays, has quietly removed 2 of them from its public archive within the last 4 years. I have PDF copies. I will not post them here because the last channel that did received a copyright strike within 11 hours, and I am not willing to lose this channel over a document fight. But they exist. The question you should be asking is not whether this works. The question you should be asking is why, if it does not work, so much effort has been spent making sure you never hear about it. Consider the case of Edwin Gray, who in 1973 demonstrated a motor in El Monte, California that appeared to run on reclaimed capacitive discharge. The Los Angeles County Sheriff's Department raided his laboratory on July 22nd of that year and seized every prototype, every notebook, every schematic. The charges were eventually dropped. The equipment was never returned. Gray died in 1989 under circumstances his family still disputes. Or consider Paul Baumann, the Swiss watchmaker who in 1980 built a device called the Testatica inside the Methernetha commune near Linden. Visitors from 27 countries witnessed that device producing useful electrical output with no visible input source. The commune stopped allowing visits in 1999 after a group of men identifying themselves as European energy regulators arrived unannounced and tried to take photographs without permission. Baumann died in 2001. The device, as far as anyone outside the commune knows, still runs. I bring up these names not because I am asking you to believe every story about suppressed technology. I am asking you to notice the pattern. The pattern is consistency. The pattern is that every time somebody builds something that reduces dependency on the central supply, the response follows the same choreography. First comes ridicule, then comes legal pressure, then comes quiet removal, then comes silence. The Amish figured this out 100 years ago, which is why they kept their knowledge oral, inside the community, shared at barn raisings and wedding dinners and funeral gatherings where no outside recording device would ever be present. Bishop Hostetler told me the last time I sat with him on his porch in October of last year that his grandfather had been offered $270 in 1924 by a man from Philadelphia who claimed to represent a research firm and wanted to buy the coil design. $270 in 1924 was roughly the equivalent of $4,200 today. His grandfather refused. The man came back 3 more times, raising the offer each visit, eventually to $900, still refused. After the 4th visit, the coil was never spoken of to outsiders again for almost 70 years. So when you wind your own coil this weekend, using the 14-gauge copper wire and the small iron core and the method I described earlier, understand that you are not just saving money on a bill. You are participating in a refusal that began in a Pennsylvania barn in February of 1921 and has been quietly maintained ever since. You are telling Samuel Insull, 104 years after his testimony, that you are not unsophisticated. You are telling the utility that sends you a bill every 30 days that you have other options. And you are proving to yourself that the grandfathers were right, that simple materials and skilled hands can still do what complicated systems charge a fortune to accomplish poorly.